First off, I did not get your test graded this weekend, so I will hopefully get those done very shortly. But it is kind of a busy beginning part of the week for me with pink event tomorrow. So there's that. We're going to start Unit 2 today. Unit 2 will take us, we will test on Unit 2 on the 15th of October. So that's a 3-week week, because guess what? It's already the last week in September. Okay? So, so the 15th of October will be your Unit 2 test. Unit 2 will take us on the relations and functions journey, the start of it. We will be graphing lines, we will be graphing inequalities, we will be writing equations of lines, we will be graphing absolute values, we will be graphing absolute values and inequalities. There's a lot of good stuff here in we will be partaking. Okay? So let's start that journey right now. Okay? So a relation is a mapping or a pairing of inputs values with output values. If you think back to when you were in Algebra 1, you had a function machine. That's how they first introduced functions to you. You put a number in the top of the function machine, and then the function machine churned out an answer at the end. And gave a value coming out. Okay? So the input was the x value that went into the function, and out a y. So inputs on x's, outputs on y's. Within a relation, there comes two fantastic parts. There's the domain of a relation, and there's the range of a relation, which is simply just a list. Okay? In math, we call lists sets. Okay? So it is a list of all of the input values. Move that up there so you can actually see the X there. Okay? That is the domain. The range is the set of all output values. Now, within that list, we don't like to have repeated values. So we wouldn't write down, like if there was 2 inputs of 7, we would only write that in our list once. Okay? Or if there's 3 outputs of -4, we would only write that once. Okay? We only write those, we don't repeat any values in either one of those lists. Now, because truly they are sets, we need to talk here a little bit about set notation. Okay? Now, set notation uses these fancy squiggly type things. I mean, they're brackets, but they're not really brackets because they're bougie brackets. Okay? All right? So, me, I'm only good for one. Like, I can only do half of the pair kind of a deal. And then I get all like my other one looks goofy. Okay? All right? So, and if you got to write down the domain and you got to write down the range, that means you got to do 4 of them. So I'm good for 1. I got to write 4. The other 3 are just not pretty. Okay? So because you are in my class and I'm not very good at doing these, I will accept squiggles. Okay? But it's got to be bigger than your number. Your squiggle's got to be bigger than your number. Make sure that it doesn't look like as long as, you know what I mean? Okay? And I'm okay with that. Okay? Because, let's be honest, I'm not good. Okay? All right? Yeah, of course. Okay? Now, there are 4 different ways to represent a relation. Okay? So the first way that you can represent a relation, and sometimes this works, sometimes this doesn't, is you can represent this with ordered pairs. Now this relation I am going to show you on all 4 of the representations. So I'm going to show you these 4 points in my representation here. Okay. So the first one is ordered pair, which if you think about an ordered pair is usually x, comma, y. Well, that is also, whoa, tap the brakes, come back to me. That is also input, comma, output. Yep, exactly. Which is also domain, comma, range. Okay. So an ordered pair is many, many things. All right? So that's one way of representing your relation. Another way is you can make a table out of your points. Okay? And again, it would be x in the first column, y in the second column, or input in the first column, output in the second column, or domain in the first column, range in the second. Now the next way, Rod, I know you're not going to like. Okay? I already know. I get it. But it's still a way to represent what? Yep, exactly. That's exactly what it is. Okay? We can represent our relation in graphic form. Not many people
He
like
put words in my mouth.
Not many people like graphs. Guess what? Unit 2 has a lot of stuff in graphing. There's a lot of graphing. Okay. But that's okay. We'll get through it together.
Yeah, it's fine.
Okay. On a graph, remember we have x's are horizontal, y's are vertical, or inputs are horizontal, outputs are vertical, or the domain is the x's, that's the inputs, and the range is the y's, the outputs. Okay, so we got a lot of stuff going on there. Okay. And the last way is probably kind of a little bit new for you. Okay, and that is called a mapping. Okay, now a mapping takes all of your inputs and puts them in a circle And then it takes all of your outputs and puts them in a circle. And then we draw arrows from the input to its corresponding output. So the point 4, 2 would be this one right here. Okay, because we've got an arrow coming from the 4 and ending at the 2. So that would be the point 4, 2. Which would also mean that this would be your domain over here. And this would be your range over here. And again, if you'll notice, in a mapping, we don't repeat anything. We have 4 values for 4 inputs, but we only have 3 in our domain because the 4 is represented twice. On the output, we have 3 values in our map because -1 is shown up twice. Okay? Questions, comments, concerns, clarifications on that? Let's do some maths with this thing. So here is a relation, brand new one. I would like you to find me the domain, the range, and I would like you to draw me a mapping of it. Cool. All right, so here's what I got for this one. I got it for the domain, and you can just use a capital D for domain, and then we got a little squiggle action. I got -3, 2, 5, and 8.
So you're supposed to list that.
Just straight out list them up. Yep. Now, do they have to be in numerical order? No. Is it nicer if they are? Oh yeah, because it makes it easier. And let's be honest, it's all about this pretty face right up here. The sooner you realize that, Roz, the easier life gets for you. When you realize that this is a Linsmeyer-centric world, your life is smooth sailing after that. Okay? Range, then, squiggle, would be -1, 4, and 7. I wouldn't rewrite that second 7 because we don't have any repeats. Okay? My mapping, then, I would take all of the elements in my domain, and I would take all of the elements in my range, and then I draw arrows betwixt them. So 2 goes to -1, so like that. 5 goes to 7, like that. -3 goes to 4, like that. 8 goes to 7, like that. And there is my map. Betwixt? Some of them are made up, I'm not going to lie to you. Some of them are actual real. Betwixt is an actual real word. Between. It's old
Why
English.
can't you just say between?
Because between is so like generic and boring.
Okay, well, would you rather have people understand what you're saying or say
Did you
something?
not understand betwixt?
No.
Well, then you should say, Miss Wismer, what does betwixt mean?
I mean, this isn't English class. This is math class.
But you should understand things, right? Oh, I know. So mean, making you be
Knowledgeable.
have some knowledge with everything. Love it. All right. So, a function is a special relation, just like you are all special people to me. Okay? A function is a special relation for which each input has exactly one output. So what that basically means is each element of the domain is assigned exactly one element in the range. For lack of a better wordage of it, it really means that there are no repeated domain values. That's what it is, that there are no repeats in the domain. Each domain has a different output. Now, can there be repeats in the range? Yes, and it still would be a function. That's okay. We just can't have any repeats in the domain. So we're basically, in the next, underneath this little shade here, it says we need to decide if each relation represents a function. So we look here at the x values. There's one. Oops, that was not so good. There's one. There's one. There's one. And there's the last one. Are any of those values repeated? No. So then this relation is a function. Big exclamation. What about this one? Function, not a function. Why not?
-1.
Negative 1 shows up twice. Okay? Right here. And right here. So that is not a function. Love it. Like that.
Smiley face.
Okay.
How can we tell if a graph, so we can look at a list and we can look at repeats in the x values to determine if it's a function. How can I tell if a graph is a function or not? What do you got, buddy?
Well, if it overlaps, then
Okay. So how can I tell if it overlaps?
well, if you see the spiral, then you overlap.
Okay. So is there a test that we might have?
Yeah.
Ooh, but I don't have any. I just got a picture. Anybody know? What kind of a straight line? A vertical one. Yep, a vertical line. We have something out there called the vertical line test. Okay? And a vertical line, if you run it side to side across your graph, that vertical line can only ever touch your graph in one spot. If it touches it more than one, not a function. Okay? Now, give me some examples of vertical lines that you can use to do this vertical line test. You can use your pencil, a ruler, your hair,
A piece of paper.
a piece of paper,
A pen.
a pen. What do you have, Rick?
ID.
Your ID,
My foot.
your foot, your hand. Can you use your hand?
I guess.
It's straight enough. Okay. What else could you use?
Your shoe. Your knowledge.
Your knowledge. As soon as you should be able to run a vertical line across it in your brain. Yep.
Not allowed in class.
I know, but you can still use it, right? On your homework, you can run it across. Okay. Right. So there's lots of things that you can use in order to do this. Okay. So so there's my vertical line. Okay. So I need to basically just slide it across. Only ever touches in one spot. So then, yes, by all means, this is a function. Then we go to the next one. Only is ever touching once, only touching once, only touching once, only touching once, only touching once, function. But then, Bugsy, you were telling me no go, right? Like 4 or 5 times? Because it's going right there, it's going right there, it's going right there, it's going right there, right there, and right there. Yeah, 6 times. So, not a function. Look like one of them swirly, like cinnamon-y
So I like second half movement.
cinnamon roll. I couldn't think of the word cinnamon roll, even though I said cinnamon-y. I got it, and then I didn't. I'm sorry that I let you down. I'm over it. Okay. Now, a special type of function out there is called a linear function. A linear function is a relation that is a function that graphs or maps into a line. Okay. Normally, we have this as y equals mx plus b. That's our normal form for a linear function. Okay? And that's what we call an xy notation. Y equals mx plus b is xy notation. So for instance, y equals 3x plus 5 is a line with a y-intercept of 5 and a slope of 3. We'll learn all of that coming up this week, next week, and the week after. Okay? So we have that. But we can also write that in function notation. Function notation now brings in this f and an x in a set of parentheses. And that is read f of x. Okay? It's not fx, the TV station. Okay? It's not f times x. It's f of x. So that means that that is the definition, the name of a function that has x as its variables. Oh. Okay? Give you a moment to get that written down. Our variable. Okay. We could have f of m, and m then would be our variable in the relation. Love it. So we can take functions, and any function that we have, and we can evaluate it at certain values of x. So for instance, what we're going to have here is we are going to have f of x equals some relation. And then what this is going to do is this will become some number, and then we will have that, we'll plug that number into our relation and get an output value. So for instance, I am defining f of x as 3x minus 4. And I want to know what f of negative 2 is. So how I would go about writing that is, I would say here f of negative 2 is equal to 3 times negative 2, then minus 4. Because I replaced x here with negative 2, I'm going to replace x in my relation with -2, and then I'm going to do the math. 3 times -2 is -6. -6 minus 4 is -10. So I write this out. My answer is f of -2 is -10, which tells me that when I input -2 into my relation, I get out an output value of -10. Now, you're going to want to divide by -2 there. You're going to say f is 5. Okay? But that's not true, because we don't want f. We're not solving for f. We're finding the value of our function with an input of -2. Okay? What I would like you to do now is I would like you to find me h of 4 and j of 2. So h of 4 then is going to be 2 times 4, then plus 6. 2 times 4 is 8, plus 6 is 14. So this would then be h of 4 would equal 14. Agree? J of 2 squared, excuse me, is 4.
That's how you do it?
Yep. Because the squared is only controlling 2. Yep. 2 squared is 4. Times 3 is 12. 6 times 2 is 12. 12 plus 12 is 24. Minus 5 is 19. So J of 2 is 19. Questions, comments, concerns, clarifications? That is all that I